Hi everyone, we're going to be talking about graphs of logarithmic functions. So we are on page 129, exercise 4G, and since you'll be asked to do number 1 and B, let's go ahead and do 1C together. So we are given the function f of x equals log base 5 of x minus 2 in parentheses and then minus 2. And here they say that x is greater than 0. Now, this right here is not the function, but this is the function of log base 2 of x. It's just a sketch. And so what we can see is for the parent function here, the vertical asymptote is actually at x equals 0. Okay, and that the domain has to be greater than 0. So you can't have a non-positive number here. X cannot equal 0, and x cannot be a negative number. When you take a log, you have to take a log of a positive number, and that's going to determine the domain for our functions here. So for number 1, and then part 1, we want to find the domain and range. So let's go ahead and take a look at this function. And we see that we have log base 5 of x minus 2. So whatever is inside the parentheses, whatever you're taking a log of, this expression has to be greater than 0. It has to be positive. So therefore, the domain is going to be any number which is greater than 2. So we will write that here. So the domain in set notation there we go, is equal to x such that x is greater than 2. Okay. So now what we're going to do is find the range. Let's do this real quick in interval notation as well. Okay, in this case, the range for a logarithmic function is going to be all real numbers. So this function, if you look at the parent function, never stops going down towards negative infinity, the y values, and it goes towards positive infinity, the y values, as x goes towards infinity. However, it goes very slowly, but it does never stop going towards positive infinity. In this case, we can say the range is equal to y, such that y is all real numbers. And of course, we can also write that in interval notation. Okay, let's look at part 2. Alright, part 2, we are asked to find any asymptotes and axes intercepts. Okay, so in order to find the asymptotes for a logarithmic function, we want to look for the vertical asymptote. And we already have a clue here, looking at the domain, that x has to be greater than 2. So if you take a look at the actual function, let's go ahead and graph it. I use Desmos. You can see that there is a vertical asymptote, and it is at x equals 2. Okay. Is a vertical asymptote. Okay. And there is no horizontal asymptote. Now we want to find the intercepts. So we know that the x-intercept is when y equals 0. So let's go ahead and plug in y equals 0, 0 for y, so we have 0 equals log base 5 of x minus 2 minus 2. Okay, So what we need to do is isolate x, so we'll add 2 to both sides. Okay, and now what we're going to do is we have to take each side, and it's going to be 5 to the power of each side. So we have 5 squared is equal to, if we have 5 to the log base 5 of x minus 2, that is going to equal x minus 2, okay, because we want this x minus 2, okay. And now we have x minus 2 is equal to 25, so x is equal to 27. So let's see if that makes sense. Let's take a look at our graph. Does it hit at 27? It does. So that's good. Alright, now let's take a look at the y-intercept. And the y-intercept is when x equals 0. So I'll put the y-intercept is when x equals 0. Let's plug in 0 for where x is. So log base 5 of 0 minus 2 minus 2. Oops. Okay, now we can already see we have a problem because this number right here, is equal to negative 2, and you cannot take the log of a negative number, so therefore there is no y-intercept. And if we take a look at the graph, see here, we can see that it never does cross the y-axis. Okay, part 3, we're going to sketch the graph showing all the important features. And so we have the graph here, but let's go ahead and sketch it. So here is my x-axis, here's my y, and we have the vertical asymptote is at x equals 2. So here's my x equals 2. We have to mark it off with a dotted line, and I will write the equation of the line. Okay, and then we have the graph itself, and we know that the x-intercept is at 27. So that's going to be way down here. So this is not going to go to scale. We're just going to write down here 27, comma 0. This is definitely not to scale, but you get the picture of what the shape of the graph should look like. Okay, so we have the asymptotes and the intercepts. Of course, this is the y, and this is the x. Okay, we want to see for part 4 to solve f of x equals negative 1 algebraically and check the solution on your graph. Alright, so what we're going to do is solve f of x equals negative 1. Okay, so f of x equals negative 1, and then that's equal to log base 5 of x minus 2 minus 2. Okay, so add 2 to both sides. Minus 2. And then we can think about the loop. Let's put the 1 here. Okay. we have 5 to the 1 equals x minus 2. And so therefore x is equal to 7. Okay, so does that make sense? We have the ordered pair 7, negative 1. So we have 7, negative 1, which would be somewhere kind of around here. And that makes sense. And of course, on the actual graph, we see that it is 7, negative 1 right here. Seven, negative 1. Okay. Okay, and then the last thing we're going to do is find f inverse of x. So this is part 4, and then part 5. So f inverse of x, okay, we want to find f inverse. So what we need to do is switch the x and the y. So now we're going to switch, and we get x is equal to log base 5, and I'm going to put a y minus 2 minus 2. Okay, so we want to isolate y, so I'm going to go ahead and add 2 to both sides and switch this over here. And we have x plus 2. Okay, so we know that 5 to the x plus 2 equals y minus 2. And then the last step we're going to do is add 2 to both sides. And we get 5 to the x plus 2 minus 2. Okay, and that is not the final answer. The final is this is equal to f inverse of x. Now, 5 to the x plus 2 minus 2. X, yeah. So let's go back to Desmos and let's check it here. So we're going to put in 5 to the x minus 2. Oops. 5 to the x minus, oops, I gotta put it in parentheses. There we go. And then, oh, it's x plus 2 minus 2. Okay. X plus 2 minus 2. Alright. Actually, let me have this equal to g of x. Okay. Okay, now let's take a look at this graph. And then the last thing I want to do is graph y equals x. And that doesn't look right. Is that right? This should be negative 1, 3, 3, negative 1. Did I do something wrong here? 5 to the x plus 2 minus 2. Okay, so we have log base 5 of x minus 2 minus 2. Add 2 to both sides. Oh, here. Y equals, this should be a plus. Okay. Alright, now let's go back here. This should be a plus. Okay, now let's take a look at the graph. Now it looks like it is a reflection across the y equals x line. And that is why it's so nice to check the graph, because algebraically you might have made a mistake, and then if you look at it, if it doesn't look like a reflection, then you know you did something wrong. So this is my f inverse of x.